Okay. It's interesting, I'm coming after Zidong. He left his job in Winnipeg and I stepped in, so watch out, I might be coming after you in China. Yeah. So I'll talk about a luminex assay that we're developing in the lab for detection of antibodies to foot and mouth disease and vesicular stomatitis viruses. So, as most of you know, actually, foot and mouth disease and vesicular stomatitis are clinically indistinguishable, especially in cattle and swine. And so tests are required to distinguish between the viruses. And I guess the first line of testing this time is going for a real-time RT-PCR. And then antigen detection, but depending on the stage of the infection, you also want to look at antibody response. And so we have competitive ELISAs, and those are available for foot and mouth disease and also for vesicular stomatitis. The good thing with the ELISAs is that the reagents can be used to adapt them for a competitive luminex-based immunoassay. So the objective here was to develop a competitive luminex-based immunoassay for FMDV and also for VSV to detect antibodies. And the rationale being that luminex-based assays are relatively faster than the ELISAs, and then you require less samples. 25 microliters will be enough to use for this test. And then they are relatively more sensitive, and then they, when you multiplex them, then there's that chance for a high throughput, and then multiplexing also further reduces the amount of sample you use because you can detect many, you can test for many analytes in one test. So for the materials that were required, it's the same that we use for our competitive ELISA for FMD 3ABC, so recombinant antigen. And then in this case, instead of using a plate that is coated with the antigen, we use this Markplex beads, which come in different fluorescent regions, and so for the FMDV we use the bead set 44. And then we have in-house developed monoclonal antibodies, anti-FMDV3B monoclonal antibody. And then of course the negative samples, sera from pigs, cattle and sheep in Canada, which is of course FMD free. And then for positive samples, we got experimentally infected pigs and cattle, and then sheep. And then for VSV, we used a recombinant glycoprotein, and then the bead region 46. So the good thing with luminex is that with this, what makes it possible to multiplex is that we have this different bead sets, which based on the fluorescence, you can distinguish between analytes. And then in this case, we had a mouse polyclonal anti-VSV New Jersey antibodies, and then negative sera again from pigs and cattle. Canada is also VSV free. And then for positive sera, we got from experimentally infected animals. And how does the assay work? So the beads, so we coat the beads with antigen. And then once we have the antigen-coated beads, you can put them in a well, in the 96 well plate. And then we add the monoclonal antibody. And then the monoclonal antibody is specific for the antigen, so it binds the antigen, and then we come with a detection antibody, which is conjugated to phycoerythrin, or PE. And then this complex is now put into the Markplex machine or the luminex machine, and then the readout is fluorescence, so we get the mean fluorescence intensity, or the median fluorescence intensity, sorry. And so for the competitive format, so if we combine the monoclonal antibody with serum from, or positive serum, then there is competition for binding to the antibody on the beads. And so the 3ABC specific antibodies in the serum will displace the monoclonal. And so when you come to detect with this detection antibody, there's only one, just a schematic display. So we assume there's only one monoclonal antibody for the detection antibody to bind to. And so we have this reduction in the median fluorescence intensity. And then if you come with the negative serum, there is some non-specific binding, but it's not as strong as with the positive serum. So you see some degree of reduction as well. So with this information, you can calculate the percent inhibition. And of course, with this median fluorescence intensity, there's 75% reduction in, 75% inhibition relative to the monoclonal antibody alone. And then for non-specific binding, there is about 25% inhibition. Okay, so I will. I'll use the statistical analysis just to show the results. And so the data was analyzed in Excel stat, and this is the number of observations, well, the number of negative serum from the 3 species for FMD. So we had cattle, pigs, and sheep. And then the positive observations, that does not necessarily correspond to the number of animals. It's just the number of bleeds from when the animals seroconverted. And so with this information and inputting the data into Excel stat, a cutoff was automatically generated, which was approximately 58%. And at this cutoff, it gave a sensitivity of about 90% and a specificity of about 98%. And so this just shows the distribution of the negative serum samples relative to the positive. And so looking at analytical sensitivity relative to the FMD 3ABC C ELISA, if you look at the green as good or positive, and then you find that there is the C ELISA and the luminex assay pretty much comparable in serum samples from cattle. And then maybe some slight advantage for the luminex assay relative to the C ELISA for serum samples from sheep. And then you look at porcine serum samples, and it seems the luminex assay is relatively more sensitive. So to conclude this part, we have successfully developed a luminex assay for detection of antibodies to FMD 3ABC in porcine, bovine, and ovine serum with a sensitivity of about 90% and specificity of about 98%. And the assays are comparable. That's C ELISA and the luminex assay. The luminex assay might be slightly more sensitive than the C ELISA. And then looking at the assay performance for VSV New Jersey. So again, that is the number of samples from pigs and cattle. And that we excluded sheep this time because they are not as susceptible to VSV. And so again, inputting the data into Excel stat, it automatically generated a cutoff, which is about 21% inhibition. And with that, we see a sensitivity of 93% and a specificity of about 95%. And again, this shows the distribution of the positive serum relative to the negative. Okay, and And then this shows the response pattern in VSV-infected pigs and cattle. And we start detecting antibodies by day 14 post-infection in pigs, and also, and then by day 7. But there is the error bar is quite wide. So, and then again, comparing the analytical sensitivity between the luminex assay and the C ELISA for VSV New Jersey. It's the luminex assay is apparently more sensitive than the C ELISA, and in this case we had samples from pigs only. I mean, to compare in the assay. So again, we have successfully developed a luminex assay for detection of antibodies to VSV in porcine and bovine serum with a sensitivity of about 93% and specificity of about 95%. And, this changed, but the luminex assay is more sensitive than the C ELISA for VSV New Jersey. Based on porcine serum that we have looked at. So overall, I would say a competitive luminex-based assay for FMD and VSV, I mean, these are feasible and they can be, I mean, there's potential to make them really highly sensitive. And then the advantage is this can be multiplexed to simultaneously detect antibodies to FMDV and VSV in the same test. And we'll continue to validate this assay, and then we'll also develop a similar assay for VSV Indiana. As you know, there are 2 serotypes of VSV, so it will be good to be able to have an assay for both serotypes and then combined with FMD. And so we'll eventually combine the 3 assays and have a multiplex assay for FMD and VSV. And with that, I'd like to thank my team. And then also funding is provided by the Canadian Food Inspection Agency, and then we had in-kind support from BioVet in Canada. Thank you.
Thank you, Charles. Very nice presentation.
Thanks.
Are there any questions?
Nice talk, Charles.
Thanks.
I just want to ask, because the instrument you used is a Luminex 200, or which one you used?
Yeah, the Mark Pigs.
Okay, yeah. So from beginning to end, how long is it going to take?
How long will it? Yeah, if you have a full 96 well plate, it takes about 46 minutes. Yeah.
Okay, that's good. So, but it's sometimes quite, because for this assay, sometimes non-specific, so the background is quite high.
Yeah, if you do the, say, indirect assay, right, the background is really high. So with a competitive assay, it's, I mean, the background is reduced significantly because competition will be to the specific epitope, right? But there's non-specific binding to the beads, which can complicate the assay, yeah.
Okay, another question from Amy.
Have you evaluated the stability of the coated beads?
We haven't done a full evaluation, but from just what we have done in the course of developing the test, at 3 months after we've coupled the antigen to the beads, they are still good. So I think they can go beyond 3 months.
Okay, one last question. I saw Jose.
Actually, I had the same question. My question was, how long can you store the antigen-labeled beads?
Yeah, so I mean, we've done that up to 3 months. So I think it can go even beyond 6 months. And then there are commercial kits that have antigen-coated bits, and they recommend, the stability of up to 1 year. So, and with storage at 4 degrees.
Okay. We have to finish here because we have to move on. So,
Okay, so the next speaker